Hi, I'm Mike Santora, Associate Editor for Design World Magazine and Make Parts Fast. And today I'm here at the RAPID show this year with Aaron Frankel. Aaron, thanks for being with us.
Thanks for having me, Mike.
Okay, so we spoke a little bit earlier about a partnership, or I should say an application that you had been working on with HP. Can you tell me a little bit about that, the project and how it came to be?
Yeah, we recently announced that Siemens and HP are deepening our partnership to industrialize additive manufacturing, meaning, let's accelerate the adoption of additive manufacturing, not just in the design area, but also in the production environment. And so in doing so, we wanted to work together to show the industry what's possible with not only additive thinking, but also additive production. So we worked together with HP to optimize a very important component that goes into HP printers. I don't know if you knew this, but HP is actually printing parts that go into their printers that they sell to customers.
Right.
And HP has done a really good job of being able to leverage additive to remove cost by consolidating parts. And the consolidation of parts can only be printed. But we thought that maybe we can take this whole way of thinking to a new level. And so what we wanted to do was look at how additive manufacturing can not only help us remove costs in some cases, but also improve performance of the overall system. We worked together with HP engineers to look at an air delivery system that ultimately cools the print heads on the HP printer. And how can we improve the flow of air through this system so we use less energy to push the air through, but also be able to push more air through the system to keep those print heads cooler, which can have an impact on printing performance and also how frequently you have to replace the print heads. We looked at the conventional design and we leveraged generative engineering algorithms and simulation to simulate the flow of air through the system and ultimately identify the best flow path in order to get the greatest performance for cooling of the overall system. And we came up with a very funky shape. It almost looks like it's sticking its tongue out at you. But we reimagined the intake where the air is getting pushed in the beginning of the system, and we came up with something that's very organic that can only be 3D printed. This resulted in about a 20% improvement in mass flow rate through the system and can have a significant impact on the overall performance of the machine.
Can you tell me a little bit about what Siemens is doing to have software help additive manufacturing and how that's going to help design engineers with their products?
We're developing software to help automate design exploration. We're giving designers and engineers tools where they can set up the problem, the constraints of the problem, the target performance objectives, and then leverage the power of computing to look at that design space and offer up solutions. And then make it very easy to take those solutions, make them CAD models that we can then analyze for printability and, let's say, cost reduction or packing into a print volume to maximize the value of that whole design cycle and be able to confidently send those parts to the printer so that they print right the first time. And I think that software is critical to helping the overall community of designers and engineers, regardless of what industry you're in, to be able to apply new ways of thinking.
Well, thank you again so much for your time, Aaron, today. I appreciate it. Can you tell everybody where they can find out more about Siemens and additive manufacturing online?
You can find out more online at www.siemens.com/PLM/additive manufacturing.
Nicely done. And of course, for more videos like this, you can go to designworldonline.com.